Hi everyone. My name is Lawrence, and I thank you guys for joining the this breakout room. So here I'm just gonna share with you the just a brief introduction about the company. Um, the Let's go to the agenda. It's just a little bit about us. The presented opportunity to the potential innovators here who are interested in helping us with this particular problem statement about heat waste capture, and just kind of run through this general problem statement and what essentially SLE can do, and how can we help you guys to also bring any of these innovative solutions pertaining to this problem statement to market. So just further down, so so Shing actually is a local-based solutions provider for engineering and construction services in Singapore. So we've been established for over 30 years, and we specialize in basically um, maintenance, construction, a lot of these industrial-based mechanical engineering solutions to some of these energy service providers. So we work with a lot of energy companies, ExxonMobil, Shell. We also work very closely with manufacturing industries such as pharmaceutical companies that actually have local-based manufacturing plants here in Singapore. So the general overview about process industry, which is sort of the overarching category that we want to introduce this particular solution for low heat waste capture that into some of these broad subsectors within the process industry. So ranging from specialty chemicals to energy-based companies, namely, for example, natural gas companies that have plant refineries here in Singapore, and also manufacturing plants based out here, like in pharmaceutical plants here in Singapore. So what is the opportunity here? I think so. The general broad themes for this sustainability open innovation challenge, really it's about trying to bring innovative solutions to realize the following three categories, right? In carbon, achieving Singapore's goals in achieving net zero carbon by 2050, and sustainability goals as well, and obviously not to mention what is it in for clients that are actually looking to implement this particular solution, which is also to try and boost profitability. So how does that actually tie into the problem statement, right? So currently this is basically an overall estimation on the 2022 total energy usage in Singapore. So the breakdown for energy consumption for industrial usage, which is used for energy used to manufacture products, is actually consuming about 22.6 terawatts, right? So what's that convert to, which is about if you actually use an iPhone, you can actually use it for a long time, right? Or you can power tens of millions of iPhones in a year's time. So how does that even translate down further deeper into the problem statement? Is to actually develop a scalable and economically viable technology that convert heat waste into reusable energy. So even when, say, we burn hydrocarbons or fossil fuels, a lot of these energy conversion from natural gas or oil, a lot of these energies is actually lost due to heat, right? And about 34% of the actual conversion of the energy is actually used for its intended purposes. So it presents a lot of the opportunity for innovators like yourself to actually tap into this particular opportunity space to bring in innovative solutions that can help clients that at Shing works with, or in the case, our problem statement is no different from the next presenter, Tata Steel. It's just the degree of temperature that we're trying, or the low heat waste quality that we're trying to capture in and convert it to meaningful, sustainable energy. Okay, so what are the existing challenges that a lot of my clients are actually facing? So a lot of these is much due to the technology limitations and the economic efficiency in terms of implementing these solutions, right? So I can dive a little bit, just briefly touched on the two existing solutions out in the market. And first and foremost, it's really these primary two power generation technologies that attempt to actually capture some form of heat waste. And the first one is actually steam turbine heat engines. The challenge here for us to propose a solution to use steam turbine heat engine to, in some ways, harness the temperature is that it requires, if you can see, it's about 260 degrees Celsius. And the cost of maintenance is actually relatively high. So it does not really fit into the purposes for the clients who are actually looking to capture heat waste that falls between the 60 to 80 degree range. There is also an existing solutions currently out in the market, which is already, I presume, is widely used in many applications. For example, portable thermoelectric generators that are attached to vehicles to reuse some of these heat to recycle this heat waste into electricity. The challenge is that the conversion efficiency rate is actually quite low. It's only from 1 to 5%, despite the portability and the benefits to it. So it's really kind of in the sweet little paradox, this sweet little mix between applying a viable solution that can drive higher efficiency than a traditional thermoelectric generator can do, while also be able to embrace low heat waste, which is 60 to 80 degrees. So the role that the company basically can take is to kind of help you contribute a lot of industry know-how. So we understand our clients very well. So we don't serve one particular domain or one specific client. We have multiple clients who are all at some point are producing in part of the manufacturing process. So in the industrial applications are numerous, right? So we can actually help you to build that pilot program, getting it test piloted in a client site. We can also help to scale this particular solution from start to finish. So that's the proposition that we can bring. And obviously, with Enterprise Singapore, with SLE in general, we'll also be open to providing funding to any innovators who can come up with solutions that can address this particular problem. I can also share with you one more slide, which can actually give you a schematic of what a typical pilot setup for a manufacturing facility would be. Are you able to see this, everyone?
Yes.
Okay, so this is a very general schematic of what a standard facility would be using to try to harness the heat waste, right? So if you look at the first part of it, so for example, they're just going to throw in an engine powered by biodiesel fuel, and they're going to use this particular energy source to power the facility, right? But at the same time, through this particular engine that is powering this facility, they will be also using, they'll have chilling uses for it. But there are a lot of heat waste that is actually coming out from this particular engine itself. So we're trying to actually see if there's an opportunity within this space to actually capture more of these heat waste and then channel it back into the facility for further use. So the cost benefit is really about how much of these biodiesels can we not use to burn, how many engines can we potentially save from not deploying in from a capacity standpoint, and what are the other applications or uses can we use the heat waste for. So just to kind of give you a general understanding of the typical problem statement, or sort of like an on-site situation that this potential solution can come to use. With that, I am at the end. I hope it's like 8 minutes, right? So I hope I didn't go over too much. So thanks for your time. I'm open to any questions. If not, then I'll pass it to the host or to Tapastil for the second presentation.
Thank you, Lawrence. Yep, I think now let's open the floor for questions. So for those who are in the room, you'd like to ask any question, feel free to just type in. So I think first question from Ivo, if I'm pronouncing it right. He's asking if, are you open to digital solutions as well?
Thanks for the question. Digital solutions, certainly open. I'm just trying to, if I don't mind, can there be any specific angle in terms of how this digital solution will be provided? Sorry, I mean, the short answer is yes.
Or can we do only chat, Diva?
No, you can talk. You can talk. Yeah.
Oh, okay. No, that helps. We provide digital twins for heat networks. So also the steam network, for example, and it can be how we help different industries in refining or chemicals and also testing different setups. So if you have different scenarios, one or two additional boilers or different hardware setups, and to both in the dimensioning and the setup, but also the energy efficiencies, for example, and then having the dynamic simulations, and then later on the real-time balancing of the system as a whole. There are different applications. Yeah.
Yep. Thank you for the sharing. So I think the client is very much open to solutions that either is it from a real time physical standpoint, or whether is it through using digital solutions to optimize, I suppose, or kind of simulate the deployment of these energy sources. I think that could be potentially one way to think about it. Certainly, so the second part to it is that the client is definitely very open to options like that. I think it's really about trying to propose a viable pathway to design, build, and then subsequently operate this particular solution. Would this digital solution be something that is during the designing phase, or is it something that can be applied throughout the life cycle of the solution, or basically the plant itself? Any thoughts on that?
Yeah, good question. If I understand you, what is I think the answer is both. So if you have a good, accurate representation of the system, They can use it to simulate new designs, but we can also connect it to the operation, so the PLC type of control, and then use it to optimize in real time for energy efficiency. And so mass balance in the steam network, eliminating or minimizing venting, those types of to optimize the efficiency. So both in the design and throughout the life cycle. Thank you.
Thank you. Thank you. Yep. Thank you.
Yeah, and great to hear you're open for this. Yeah,
yes,
helps.
Definitely open. I think we can definitely connect on this. I am just trying to like suss out what's the how certainly I think sorry, because my screen is still now in sharing mode. I can't conceivably open up. Otherwise, I have to see your face. Hi. So, Evo. Can I stop sharing my screen, or do I keep going?
You can stop sharing.
Okay. So thanks, Evo. I really appreciate you sharing your thoughts on the solution that you have. I think we can definitely connect offline if that's something that you and I can try to discuss this further. Certainly, I would like to kind of continue to leverage on the SOIC platform to try and see if your solution can be used even for Tata Steel's problem statement as well, because I don't think there is really that much of a separation. It's just the degree of or the quality of the heat waste, right? So why don't you continue to stay here and hear what Tata Steel has to say? But in the meantime, I'm definitely open to hearing more from you.
All right, cool. Thanks, Lauren. Thanks, Ivo. Any other question from the floor?